Morning, everyone. Nice to meet you all again. This is my third lecture in professional ethics in engineering subject, and we are going to overview our unit 3, that is engineering as social experimentation. And I hope the two video lectures in the first 2 units have been useful for you. Now we are going to discuss about the third unit, engineering as social experimentation. So what are the contents? First of all, we are going to see what are the contents in this third unit. Engineering as experimentations and engineer as experimenter. Engineering experiment versus standard experiments. Engineering as a responsible experimenter. Code of ethics. Industrial standard. A balanced outlook on law. A case study on challenge and disaster. So these are the contents in the third unit. Now we are going to discuss these topics deeply. So the first topic is engineering and as experimentation. So experimentation plays a significant role in a design process. Usually a design process is an iterative type, therefore carried out on trial design with modification on the basis of feedbacks received at various stages. So in an engineering project, the overall process is considering as an experimentation. So for example, before you are going to design a circuit, we are going to construct a home. Before manufacturing a product or providing a project, we make several assumptions and trials. Designs are design tested several times till the product is observed to be functioning satisfactorily. So we try different materials and experiments. So in this experimentation product, several redesigns are made upon the feedback information on the performance or failure in the field of factory, and hence the development of a product or a project as a whole may be considered as experiments. So there are similarities to the standard experiments. So this is the flowchart I have given below. So you can see, before designing or manufacturing a product, first of all the design is the first important thing. So first step of manufacturing a product, we should first design about the product, and after that only we are going to fabricate it, and we have to check a physical test, and we have to run the simulation, and next thing only we are going for the prototype, plot plan and model study. So after that only it goes to the final design. The steps which I have told you now, if there is any problem in fabrication, assembly or physical test, then in against the arrow goes to the design. So it comes from the first step. So after final design goes for the manufacturing product. If there is any default in the if there is any fault identified in the manufacturing process, then again it also goes to the first step, that is designing process. So after manufacturing our project, we go for field study. In the field study, we have to observe whether the product is good or bad. If it is not good or not satisfied what the viewers want, then again the product goes to the design process. So the design process is the first step for experimentations. So there is a similarity between engineering projects and standard experiments. So it is now compared with two activities normally, similarities and contrast. So in similarities, if there is partial ignorance, in contrast that is experimental control. So in similarities it is uncertainty, then it will be in contrast it will be a human touch. In similarities it is in continuous monitoring, but in contrast it will be an informed consent. So in similarities it is learning from the past, means in contrast we have to gain knowledge. So we are going to discuss about the similarities of engineering as experimentation, or the similarities to the standard experiment. The first one is that partial ignorance. So there are uncertainties in abstract model using design calculation and processing and fabrication and price characteristics of purchased material, and also the nature of stress to finish the product exposed. And an engineer must not wait until the relevant facts to come before experimentation. So also in theoretical exploration and lab testing must be avoided for the sake of moving ahead on your project. The success of engineers lies in the ability to complete tasks with partial knowledge of scientific laws about society and nature. So, in partial ignorance, the project is usually executed in partial ignorance. Uncertainties exist in the model assumed. They may be vary with the suppliers, process lot time, and the process used in shaping the materials, example sheet or plate, rod or wire. There may be variation in the grain structure and its resulting failure stress. It is not possible to collect data on all variation. So partial ignorance is nothing but we are going to partially ignore some of the materials before after designing. So in designing process itself we came to know that whether this material will be useful for our project or not. If it is not useful means we have to partially ignore that product. The second one is uncertainty. The final outcome of the projects are also uncertain as in experiments. Unexpected risks such as undue seepage in a storage dam, leakage of nuclear radiation from atomic power plant, presence of pesticide in food or soft drink bottle, or a new irrigation canal spreading waterborne disease, and an unsuspecting hair dryer causing lung cancer on the user. So these are the uncertainty. So even though we have designed a product and we have go through the partial ignorance, after completing the product there will be an uncertain things will happen unexpectedly. So that is the unexpected risk. So for example here given that there will be a pesticide in food or soft drink bottle. No managers or no organization will do with the expectation to put a pesticide in the drinking bottle. So it is an unexpected risk. This is the uncertainty after manufacturing the product. That is next one is continuous monitoring. So in continuous monitoring continuously the progress and gaining the new knowledge that are needed before, during and after execution of project, as in the case of experimentation. So the performance is to be monitored even during the use of the product by the end user beneficiary. So after manufacturing the product, the manufacturer after selling the product to the viewer or the end user, they are giving the guarantees and warranties about the product for minimum 6 months to 5 years. This is nothing but they are monitoring the product, how it is working and how it performs. He is getting the feedback from the customers, and after getting the feedback from the customers, he is correcting what the mistake he had done already in the design. He is rectifying what he had done, what mistake he had done in his design. So this is continuous monitoring. And next one is learning from the past. So an engineer should learn not only from their own results but also from the other engineers' results. But because of misplaced pride is not asking for information, and fear of litigation and simply negligence usually impede the flow of information. So an engineer should not always rely on handbooks alone but should remain alert and informed at every stage of projects and experimentation. So engineers normally learn from their own prior designs and infer from the analysis of operations and results, and sometimes from the reports of other engineers. 40 years back, another steamship active met with a same tragedy due to the same problem in the same region. In most of the hydraulic systems, value have been the critical component that are least reliable. So engineers should not learn not only from their own results but also they have to learn from other engineers' results. Next one is the contrast. So actually engineering differs from the standard experimentation. These differences highlight the engineer's responsibility, and there are so many types in contrast. First one is experimental control. So in experimental control, members for study are selected in two groups, namely A and B at random. Group A are given special treatment, group B is given to no treatment, and it is called controlled group. This process is called experimental control. In engineering, through random sampling, the survey is made from among the users to assess the results of the product. So one of the causes of two difference involves the selection of members of two different groups. So one group may receive the special experimental treatment, while the member of the other group, called control group, do not receive any special treatment, even though they are subjected to the same environment. And the next is human touch. So engineering experiments involve human souls, their needs, views, expectations, and creative use in the case of social experimentation. But now, the quality engineers and managers have fully realized the human aspects. Next one is informed consent. So informed consent comprises of two main elements, that is knowledge and voluntariness. So in informed consent, engineering experimentation is viewed as a social experiment, since the subject and the beneficiary are human beings. So the informed consent is practiced in a medical experimentation, such as practice is not there in scientific laboratory experiments. So the two compromises main elements are the knowledge and voluntaries. So in knowledge should be given not only the information, but also they requires the information needed to make a reasonable decision. So the subject should be given to all relevant information needed to make a decision to participate. The next one is voluntariness. Voluntariness must enter into the experiment without being subjected to force, being fraud or deception. Subject should take part without force, or the subject should not be in fraud or in deception. And the respect of rights of minorities to dissent and the compensation for harmful effect are assumed here. An engineer cannot provide an essential information about the project unless there is a cooperation by management. So if the management should be cooperated to the engineer to provide more information than the required law. So then this is about the informed consent. And the next topic is knowledge gained. So knowledge gained is not much of new knowledge is developed in engineering experiment as the case. Engineering experiments are the most helpers in verifying the adequacy of the design, to check the stability of design parameters, preparing the unexpected outcome in the actual field environment. So in engineering experiment, engineering experimentation will not produce any new knowledge, but it affirms that we are right about the factor, while the scientific experiment will gain new knowledge. So if any unexpected result is obtained in the project, it is sent for the scientific experiment. So these are the knowledge gained. So this is the process of knowledge gain. So next, in the last topic we discussed about engineering as experimentation, and now in this topic we are going to see engineers as responsible experimenters. So engineers as experimenters shares the responsibility with management and society, but the expertise of engineers places them in unique position to monitor the projects, to identify risk and provide the information to society. So the engineer has an experiment of several responsibilities, namely a conscientious commitment to live by moral values, a comprehensive, perceptive or relevant information. It includes constant awareness of the program of the experiment and readiness to monitor the side effects, and unrestricted free personal involvement in all steps of project or in his own product development, being accountable for the results of project. So the third point, that is autonomy and accountability, I think I have discussed this in the video lecture 2. Even though we have discussed, we will see in the further topics, in the upcoming topic we can deeply see that. So conscientiousness is a moral commitment, means being sensitive to the full range of moral values and responsibilities relevant to prevailing situations. So what is meant by comprehensive prescriptive? So comprehensive prescriptive means an engineer should grasp the context of his work and ensure that work involved result in moral ends. So in processing of the perceptive or factual information, The engineer should exhibit a moral concern and not agree for the design. A full-scale environment or a social impact study of a product or the project by individual engineers will be useful, but it is not possible in practice. So people act responsibility to the extent whereby consciously feel the living according to the moral values. In today's working condition, where most of the engineers are salaried employees, because of conscientious moral and minimum negative duties, giving true date, non-violating, patient, not breaking confidentiality also can be viewed. So, as I told that we had already discussed in video lecture 2 about moral autonomy. So, people are morally autonomous when their moral conducts and principles of action of their own. Benefits and attitudes must be integrated into individual personality that leads to the committed action. In deciding the moral autonomy, attitude of the management plays an important role. For moral support, engineers are compelled to look to their professional ethics. So the morally responsible engineers are the one who are personally motivated to have a dedicated involvement in all aspects of projects. So next one is accountability. The term accountability means a responsible individual accepts the moral responsibility of their action. The true meaning of accountable is the general disposition of being willing to submit one's action and to be open and responsive to the assessment. So in large engineering project, there is a fragmentation of work. Each person is contributing a large project. As per fragmentation of work, the accountability is assigned within the hierarchies of the authority. So the term accountability is nothing but the capacity to understand and act on moral reasons, willingness to submit one action on moral security and be responsive to the assessment of others. So this is the accountability. And the next topic is code of ethics. So what is meant by code of ethics? So code of ethics exhibits the rights, duties, obligations of a members of a profession and the professional society. So the engineering code of ethics approved by two different societies I am going to discuss about that code of ethics, that is ABET and IEEE. ABET nothing but Accreditation Board of Engineering and Technology, and IEEE is the Institute of Electrical and Electronic Engineering. So the code of ethics has the fundamental principle that first one, using their knowledge and skill for the enhancement of human welfare, and second one is being honest and impartial, serving with fidelity to the public and their employers. Third one is supporting the professional and technical societies and their disciplines. So the code of ethics for any organization or society performs the main important following roles, that is, first one is inspiration and guidance. The first code expresses the collective commitment of profession to ethical conduct and public good and thus inspire the individuals. So these codes provide the helpful guidance about main obligations of the engineers. For concentrating the moral issues of their own interests, most of the engineering societies and companies are listed below. That is like ABET, IEEE, ASCE, ASME, Betsel, Hudges, Texas Instruments. So these are the first one in the inspiration and guidance. The second point is support to engineers. So code provides positive support for any ethical act. Code serve legal support for engineers toward the professional obligation, and also it gives engineers some backing in decisions on moral issues. So the code must give support to the engineer, that is positive support to the professional for taking stand on moral issues. And next one is deterrence and discipline. Deterrence is nothing but discourage to act immorally, and discipline is to act morally. So these codes serves as the basis for investigating unethical actions. The professional societies sometimes revoke membership and they expel the members when proved to have acted unethical. The fourth one is education and mutual understanding. So in education and mutual understanding, codes can be used for discussion and reflection on moral issues, and also to encourage a shared understanding among the professionals, and also regarding the moral responsibilities. So these codes are used to prompt discussion and reflection on moral issues. Next one is creating good public image. So creating good public image code present the positive image of the committed person to the public, and also it helps the engineer to serve the public effectively. It also gives power of self-regulation for the profession. The next code is protect the status quo. In status quo, they create minimum level of ethical conduct and promotes agreement with the profession. Sometimes the code can suppress the difference of opinion within the profession, and also a code has the positive discouraged moral conduct and serious harm to those seeking to the service public. The next code is promotes business interests. This code offers inspiration to the entrepreneurs, establish shared standards, healthy competition, and maximize profit to investors, employees, and consumers. So this code provides returns of commerces on business transaction to benefit the professions. But an undue influence can be observed by self-serving items of the codes. So some engineers believe that the codes were justified in forbidding the competitive bidding, and some engineers believe that such a restriction is appropriate. So there are limitations for the code of ethics. So the first limitation is the general and vague wordings. So this is the first limit, and second one is it is not applicable to all situations, and third one is often having internal conflicts. So in a task or in a team there will be some internal conflict between the higher authority and lower authority, or with the higher management or the lower management. So there will be a limitation in this code for a profession. And fourth one is they cannot be treated as the final moral authority for professional conducts. Code have flaws by commission and omission, and only a few enroll as members in professional society, and non-members cannot be compelled. So for example, after completing your UG degree or PG degree, you must be registered in the Indian Society of Technical Education, that is ISTE. It is not a compulsion to register, but we have to enroll ourselves in the professional society. Even as a member of the professional society, many are unaware of these codes. So different societies have different codes. For example, MIST, this stands for ISTE, and Accreditation Board of Engineering Technology stands for ABET. IEEE stands for Institute of Electrical and Electronics Engineering. NSP stands for National Society of Professional Engineers. So the codes said to be coercive. There are sometimes claimed to be threatening and forceful. So these are the limitations in the code of ethics, and these are the industrial standards, that is the quality of service, safety, uniformity. This is for purpose, and what are the examples? For quality, valuing the appropriate to price, and examples are surface finish for a plate, life corner. So these are the industrial standards, a table which I created. Next one is so we can just see an overview of industrial standard. So industrial standards are important for any industry. That is, we already know that for even a simple product are having the ISO 9001:2000 certificate, that it is the standard because it can cleanly explain whether we can use the product or not. It will be in the organization, the ISO organization are on of different symbol of colors. For green it will be herbal, for red it will be danger, for black it will be false. So there are some of the limitation industrial standards. So the specification helps in achieving interchangeability, and it helps the manufacturer, customers, and the public in keeping competitiveness and ensuring the quality simultaneously. And international standards have become irrelevant with the development of world trade. So these are the limitations in the code of ethics, And next we are going to discuss about a topic, a balanced outlook on law. So what is my balanced outlook on law? The role of engineering as social experimentation and its interaction rules with the engineering process, the role of formal rules and the ethical implications are being studied. So to work, live with harmony in society, there must be balance of individual needs and collective needs. Ethical conduct provides this balance because engineers should play an active role in engineering and enforcing them. It is the argument that the engineer's concern with ethics on job is limited to similar activities. It is the balanced outlook law on engineering practices stress the necessity of laws and regulations and also their limitation in directing and controlling the engineering practice. So these laws are necessary because people are not fully responsible by themselves and because of the competitive nature of free enterprise which do not encourage moral initiatives. So these laws are need to provide a minimum level of compliances. So this is the case study of the Challenger. It is an orbit of the Challenger that had 3 main engines filled by the liquid hydrogen. The fuel was carried in an external fuel tank which was jettisoned when empty. So during the liftoff, the main engines fire off about 9 minutes, although initially the thrust was provided by 2 booster rockets. These booster rockets are of solid fuel type, each burning a 1,000,000-pound load of aluminium, potassium chloride and iron oxide. So we have taken this Challenger as a case study, so we can see what are the moral and normative issues in this. So the crew had no escape mechanism. So and the engineer designed an abort module to allow the separation of the orbiter triggered by filled joint leak, but such a safe exit was rejected is too expensive, and because of this we have to reduction in payload, and also the crew was not informed of the problems existing in the field joint. The principle of informed consent was not followed here in this case study. So engineers gave warning signals on safety, but the management group prevailed over and ignored the warning. So this is the main reason for the Challenger case study, that is the orbiter. In the third point, you can clearly see that the engineers gave warning to safety, gave warning to the management for safety, but the management group prevailed over and ignored the warning. So in conceptual issue, what are the conceptual issues in the case study means? First one is NASA counted the probability of failure of the craft was 1 in 1 lakh launches, but it was expected that only 10 lakh launch will fail. There were 700 critically one item, which includes the field joints. A failure of any one of them would have caused the tragedy. No backup or standby have been provided critically in one component. Then the factual issues are, I already told that there is a field joint and the field joint gave way in earlier flights, but the authorities felt the risk is not high. So the management thought that even though they gave the warning, they thought that the risk is not very high. So this is one of the factual issue. Second one is the inability of the Rockwell engineers, that is manufacturers, to prove that the liftoff was unsafe. That was interpreted by NASA and was approved by Rockwell to launch. So this is the case study of the Challenger. So this case study consists of the factual issues, conceptual issues and moral issues. So I hope this video lecture will be very helpful for you to overview the third unit in professional ethics in engineering. Hope we will meet you soon in the video lecture 4. Thank you.